Hi, today we are going to take a look at this vertical gyro. This thing was manufactured in 81. This gyro is sealed, as you can see. I will need to desolder this tape here. A few moments later. Okay, so we can see the gyro here. But we can see that the roll axis is not free. The friction was due to the torque motor actually. It is possible to adjust the position of the coils using these screws here. One screw is fixed here, but it is possible to adjust the three other screws here. Okay, you can see the spring here. Okay, so this permits to adjust the position, and now you can see that the gyro is free. A little friction here, it seems. Okay, so I have readjusted the coils of the torquer here, and now everything is perfect. We can see on that side here a power diode. This diode is connected to this filtering capacitor. And we have something here which is connected in parallel to this capacitor. And actually this is a solenoid. Okay, so I think it's a kind of locking solenoid. But I don't know exactly the purpose of this one. Because I thought at the beginning that this solenoid is intended to lock the gimbal here, but actually it is not the case. We can see here the coil of the outer gimbal torquer. Okay, so when the gyro is spinning, the torque applied to this gimbal permits to modify the position of the inner gimbal. This is the capacitor associated to the coils of the torquer here. This torquer is connected to the leveling switch of the inner gimbal. We can see the leveling switch here. And there is another one here, linked mechanically to the outer gimbal. It is connected to the torquer of the inner gimbal. So we can see the windings here of the inner gimbal torquer. So this is the inner gimbal torquer. We can see here the synchro of the outer gimbal. We can see here the synchro of the inner gimbal. On that side there is a small DC power supply here using this diode and this tantalum capacitor. This is a castanet capacitor. And this DC voltage is used for the supply of various relays. Okay, we can see the relays here. And we can see the power supply transformer. So here we have two thermal relays. One is set to 30 seconds, second one to 20 seconds. We can see here one thermal relay time delay. The time delay is 60 seconds for this one. We can see these thermal relays here. One relay is used for the leveling power here. So we can see that the leveling torquers here are connected to this terminal of this relay. This relay permits to select between a voltage of 18 volts and 83 volts here. When the gyro is powered, this relay is off, so therefore a low voltage is used for the torquers. So this avoids an erratic movement of the gimbals. And after 1 minute, this relay turns on, and this permits to activate the high voltage for the torquers. Okay, we can see the two gravity sensors here. The outer gimbal sensor here is connected to the inner torquer, and the inner gravity sensor here is connected to the outer gimbal torquer. It is possible to deactivate the leveling by turning on these two relays. Pin K of the connector permits to deactivate the leveling. We can see that the coils of these two relays are connected in parallel. So it is strange because the second part of the relays are not used. Okay, so this one and this one. So I don't understand why they didn't use only one relay instead of two. This is weird. We can see that at startup, the leveling of the inner gimbal is not activated during 20 seconds using this relay here, which disconnect this line from the AC power supply here. For the test, I have used this small module for the generation of the three-phase AC voltage. It's a micro-step driver. You can see the reference. You can see the configuration of the micro switch here. And these wires are connected to this three-phase transformer I salvaged from an avionics test item. Input is in triangle configuration and there is a star configuration for the output. Because for this gyro we need a neutral and three phases. So you can see actually the primary of this transformer is the secondary, actually 208 volts, and the primary here 27 volts. Okay. The clock input here has a frequency of 51.2 kHz. Okay. I have connected the roll and pitch synchros to this ADI. This ADI is supplied with another power supply, okay, which is this one here. This is possible because the reference winding of the synchros here is isolated from the rest of the circuit, so you can use another frequency for the synchro. For the first test, I will activate only this ADI connected to the synchros. Okay. Okay, so this is the outer gimbal for the roll, and this is the inner gimbal for the pitch.